Hi, my name is Joel Clark, Grantham student ID number G00089019. Today I will be presenting to you my capstone project for EE450. For my project, I designed a motion-activated light system using the electronic simulation software Multisim. I was unable to procure components to build my system physically, so I will be demonstrating its operation using Multisim, and I will go over my design and decision-making process. Please keep in mind that some of the components that I intended to use for the design were unavailable in Multisim, so I used components that I could substitute in order to have the design work as intended. I will now demonstrate my circuit in Multisim. As you can see, I have pulled up the circuit that I designed in the Multisim software, and I will now go over the circuit and how it operates and the reason behind some of the decisions that I made. So I'll start over on the left here. You'll see that I have the 5-volt VCC power supply running to switch number 1 here. Then going down to my relay, we have a diode running in parallel, and this circuit is grounded. On the other side of the relay, we have a second circuit. We have a 9-volt power supply. We have that running through a second switch, a 1 kilo ohm resistor, and an LED, and this circuit is also grounded. So the first thing I'd like to note is that switch number 1 here, this was intended to be the PIR, the photo infrared sensor that would be used for the light activation in the circuit. The PIR sensor is not a component that's available in Multisim, so the switch was the simplest solution I could use to demonstrate the function in the circuit, because basically the way that the PIR sensor would work is we would have the 5 volts running to it, and then whenever any motion was detected, we would have an output signal that would come along this line here to the relay. And so we would have a PIR sensor here, and the relay, once we had the voltage come to the relay, it would activate this circuit. Another note that I would like to make is that the relay here is not the relay I was intending to use for the circuit. The relay that I would use would be a latching relay. The reason I would use a latching relay is because when you have the motion detector activated, it sends one pulse to the relay. A normal type of relay would require continuous current to it in order to keep the secondary circuit active. And so with a latching relay, once it got one pulse from the PIR sensor, that relay would latch closed, allowing this circuit on the right here to continue operating. The diode that runs in parallel to the relay is just a safety feature. It's basically used so that when the current is shut off to the relay, there's no voltage spike from any excess energy that might be stored in the coils of the relay. So on the right side, we have a 9-volt power supply, and then we have our LED. We have the resistor and then the switch. So basically the way this side of the circuit works is that once the relay opens and we can get current flow through the whole circuit, we have a current that's generated from the power supply here that runs through the LED, and the LED lights. So the reason I use 9-volt with a 1 kilo ohm is because the LED requires a minimum of a 5 milliamp current in order to activate. So when we have a 9-volt power supply with a 1 kilo ohm resistor, that gives us 9 milliamps. So that's plenty to power that LED. And one other note I'd like to make, just referring back to the first circuit on the left of the relay here, I used a 5-volt power supply because the relay, in order to activate, needs between 3 and 6 volts. So at this point, one more thing before I activate the circuit, I would like to note that this switch here is a manual shutoff switch, because if this circuit was built physically and we had the PIR sensor here, once it pulsed to the relay, we would have it latch and the light would remain on continuously. So I included a switch on this circuit here that we could open up in order to have the to have the light shut off manually. So I included a manual shut-off switch. So at this point, I would like to demonstrate how the circuit would work. So basically, I'll run the simulation here. And so would like to note that once we have it running here, Alright, so we've successfully started the simulation, so you'll notice that the arrow's coming off the LED here. We have no light to the circuit yet, and that's because our switch is closed. So we can just imagine here that we have a PIR sensor, it detects motion, and so the switch closing here is basically going to be a substitute for if that PIR sensor was pulsing voltage to the relay here. So we'll close that up. And you'll notice when that happened, the LED lights up, and that is because once the voltage comes through, you'll notice that right here we have the relay closing so that the circuit can be closed and we can have voltage current flow through it. So again, I'll open up the switch. You'll notice the LED shuts off. We have an open in the circuit right here through the relay, and if we close that switch, notice that we get current through the relay and the LED lights up. And then for, assuming that we would have a PIR sensor here and we would have a relay, a latching relay right here, the only way we'd be able to shut it off is to do the secondary shutoff switch. So we can use switch number 2 right here, open that up, and we no longer have power to the LED. This concludes my demonstration of my Capstone project. I hope you enjoyed. Thank you.